Well, hello everybody to my first episode of Let's Develop. My name is Sven and I'm going to practice some test-driven development in this episode, which is actually kind of a pilot for this Let's Develop project. So, what I'm going to do in this episode is I'm going to implement the basic rules of Conway's Game of Life. I just looked up these rules here on Wikipedia, and I'm going to first quickly discuss the rules before I start implementing them. So the reason I chose the Game of Life is because it's quite easy. It takes place in a universe which is actually a two-dimensional grid, and each cell in this grid is either alive or it's dead. And the Game of Life itself is round based, so with every round it is decided for every cell whether it will become alive in the next round, or whether it will die in the next round, or whether it will stay alive or stay dead. And there are 4 simple rules that determine how this happens. The first of this rule is that any live cell with fewer than 2 live neighbors dies in the next round because of underpopulation. The second round is that any live cell with 2 or 3 live neighbors lives on to the next generation or the next round. The third rule is that any live cell with more than 3 live neighbors dies, as if by overcrowding. And the fourth rule is that any dead cell with exactly 3 live neighbors becomes a live cell, as if by reproduction. Wherever we need 3 live neighbors for reproduction, but that's a discussion for another time. What I did so far is just I downloaded the Eclipse Kepler distribution for Java developers, and I created a simple Maven project with a JUnit dependency so that I can easily do some test-driven development. Okay. And I guess it's best we jump right into it. I'm going to place a logic for the cell update into a class named cell. So the first thing I do here is create a class named cell test, which will of course contain the tests for all cell class. Game of Life. Let's give this a package to avoid the default Eclipse warning, and let's jump right into it, developing a first test. So let's have a quick look at the rules. I'm going to start with the first rule, that any live cell with fewer than 2 live neighbors dies. What I usually do when I develop, when I write tests, is that I try to state what exactly the test is going to check in the test's name, and I do this by starting the test with a should. In that game, should die with only 1 neighbor. Okay, so the first thing I need, of course, is the unit under test, which is a cell. And since I did not yet create that class, I basically reached the point where I have a failing test, because I mean the test doesn't compile, so it's of course failing. And that's why I'm going to create this cell class real quick. Game of Life. And quick as that, our test compiles, and I can assign it to a local variable called unit under test. And as the fact that the cell should die implies that the cell was alive to begin with, I already want to create some initial state which I will pass into the cell via the constructor, which says, okay, I want to say something like cell.cellState.life, which is of course some kind of enumeration, which I'm going to create real quick. Public cell state, and there's a life and dead in here, which is this an enum, of course. So now this works, only that I need to create the respective constructor, and that I want to assign this value to a new field, which is this cell state. I'm going to rename this quickly because life is not really what I want to have here. So let's remove this scaffolding, and I guess that's it for now. So now I'm able to create a live cell, and I want this cell to update get next state, and I'm going to tell the cell that it has exactly one neighbor. Of course, now again I have a theoretically failing test because it doesn't even compile. So I create this method real quick, and I tell it to return an instance of cell state, and actually make it return null because that's the easiest thing I can do. What is this here? Unused imports. Okay, let's just remove some. Okay, it's not used, it's going to be used real soon. And I assign this state to a local variable which I call actual. Actual because I'm going to compare this actual next state to some expected next state with an assertion. And I kind of tend to call this variables actual, and sometimes I even create the variable expected, at least if the expected value is somewhat more than just a constant. So we have cellpong.cellState.dead, which is my expectation, and I guess this should be equal to the actual. Let's add the static import real quick. Is it static import? Yeah, it is. I implemented somewhat too much C# lately, so that I'm not familiar with the Java syntax anymore. Okay, now we have our first test, and I'm going to run this test because now for the first time I can execute it, and of course it fails because it did not implement anything. And what I'm going to do now, of course that's a little overdoing things probably for this really small example, but what I usually try to do is give it the simplest implementation possible, which would in this case be just return cell state dead. The reason why I do this is when I implement only the least bit of code necessary to fulfill my test cases, I make sure that I don't introduce any branching and stuff that is not covered by any tests. So since my first test works quite good, I'm trying to write another test real quick, which is should die with 0 neighbors. I'm pretty sure this test will work because, I mean, just because of the way I implement it, I just implemented the rule, but as Uncle Bob said, if there's an easy test to write, there's no problem writing it, so just do it. Don't think, oh, that's an unnecessary test, because I know that it works. Sometime later you might actually revise your implementation, and then exactly this case might break, and you have not covered it by any tests. So if there's an easy test case I can write, I just write it down, and just to be sure that everything still works. Yeah, well, okay, this works. 2 tests passing. On to the next rule. Second rule is that any live cell with 2 or 3 live neighbors lives on to the next generation. So now it gets interesting, because now I'm going to, of course, need more logic in my implementation. Live on with 2 neighbors. So now I'm again going to create my cell, which is initially alive. I'm going to ask this cell for the next state and tell it that there are 2 neighbors. And this is again our actual state, and this time I expect that the cell state actually is alive. And this is probably easy to see. This is going to fail. Yeah. So now I have a broken test. So I go back to my switch here, and I'm going to say, okay, if I is bigger than 1, then cell state alive, else cell state dead, which should implement what I actually want. So I'm going to re-execute the test and see, yes, it works. So it's 2 or 3, isn't it? So I'm just doing the same thing here. Implement the exact same test, with the exception that there's 3 neighbors this time, and it's still working, I'd say. Yes. By the way, I'm going to reorder this test, because in my mind it makes more sense to have the number of neighbors increasing. Okay, so my next test case is going to cover the third rule, actually, that any live cell with more than 3 live neighbors is going to die. So I say should die with 4 neighbors. If it's alive, 4 neighbors, I expect the cell to be dead afterwards. Re-execute the tests, and again 1 is failing. So the new condition is small, or if I bigger than 1, or I smaller 4, should, no, it's I bigger 1 or I smaller 4 should live on. What did I do now? Well. Now we see what test-driven development is good for, because I actually already messed it up, even though this should be some pretty easy logic. What did I do wrong? In the case of 4, I want to return that, so this should be false. So in the case of I smaller than 4, isn't it? This is exactly what I wrote before, and it seems like I messed it up. Let's see, what did I do? For 0, I returned actually return alive. Ah, stupid me. Okay, this should be an end. And everything's working now. Okay, that was definitely a demonstration of stupidity, but at least now we see what test-driven development is good for. Since I had all the tests, I pretty quickly recognized that I did some stupid stuff here and were able to fix it. So since the rule is that any cell with more than 3 neighbors actually is going to die in the next round, I'm going to add tests for the other 4 cases, which is 5 neighbors, 6, 7, and 8 neighbors, because 8 neighbors is the maximum possible. So it's 4, 5, 6, and 7. It's actually, I would really like to have some feature like the what is it called? Test parameters, parameterized tests you're able to do in C#, where you can just annotate different input values, and I could write the dead and the alive cases in just, I'd say, 2 test cases with respective annotations. Would be really cool to have this actually for Java, but unfortunately we haven't, so we have to live on with what we get so far. So what I see now is that I actually already wrote like 9 tests to cover my simple logic. In this case, it's really exhaustive testing, because there's a quite limited number of cases. But interestingly enough, I did still not check anything of my actual cell state, so it is pretty clear that there's a lot of stuff not tested at all now. So but I'm going to continue here with the rule that any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. So the fun thing is that this is probably going to work without any change, isn't it? So I just say should become alive with 3 neighbors. I create my unit under test, which is my cell with the cell state dead this time, and now I'm going to just use this nice template and say, okay, this should be live afterwards. Funny thing is that this is probably going to work, right? Okay, so now I implemented basically all the rules, but as I just said, I still did not even think about this initial cell state. So what is missing is actually like the opposite cases. But as already quite some time passed, I think I'm going to move this to actually my second episode of Let's Develop, which means this is it for now. I hope you enjoyed developing this small rule with me, and if you have some feedback, please leave comments and let me know if you have any ideas how to improve, how to do this better, or how to show different things. If you're interested in anything like setting up the project or stuff, I can definitely think about doing an episode on that. So see you guys.